Morning, everyone. Please fill up the attendance link that I've given you for the purpose of recording your attendance in this class. All right, let's continue with our lesson on chapter 2. Last class, we have looked at two formula or two equations that we can use to find depth of uniform flow. Look at the first statement there. These two formula can be used to find the depth of uniform flow, which are the Chezy roughness flow equation and the Manning roughness flow equations. This is used widely. These two equations are used widely, especially in analysis, because in analysis of flow, normally we'll assume the flow to be uniform flow to help to so that the analysis would be easier to be conducted, right? Okay, now we know that Q equals to AV, right? Therefore, we could also write the Chezy formula in terms of Q instead of V, right? So we just have another term of that means since Q equals to AV, V we substitute with CR to the power of half and S naught to the power of half. Therefore, you have the Chezy roughness flow equation to determine in terms of rate of flow. Same thing as Manning formula. These two, depending if you need to find the rate of flow, you'll just use the bottom one, all right? Or if you want to find the velocity of flow, you can just use the, without the flow area term, all right? Now, this is what we have looked at last week. So we have gone through exercise activity 2.3. So let's just go through this activity, all right? Oops. Okay, I think I forgot this guy here. Okay, now let's look at activity 2.4. Okay, before that, when we learn about these two equations, right? Now the question could be, I think so far you have tried out question where they ask you to find the rate of flow or velocity of flow using either Chezy or Manning formula. Now I could ask you question where you need to find where Q is given, rate of flow is given, or velocity is given. You need to find the bed slope, or with the given parameters, you need to find the roughness coefficient. It could be Chezy or Manning roughness coefficient, or I could give you all the variables, the data for all the other variables except the depth of flow. If I didn't give you depth of flow, that means you cannot find the flow area as well as the hydraulic radius. Okay. So now these are, combination of questions where I could ask you from these two formula. That means given a certain parameter, you need to solve it using these two equations. That means you have to, list out all the known variables. And then you have to rewrite this equation in terms of the unknown variables and then find the unknown variables, basically, right? So today we are going to look at, we are still using these two equations, However, you probably need to find, variables given. You need to find the slope, the bed slope, or you need to find, uh, the depth of flow, all right, or the roughness coefficient. Okay, now let's look at what this activity. I want to ask whether you have tried this activity out. Have you done it in the class last week? Activity 2.4? Anyone? Um, Norliana? Norliana, are you there?
Yeah, Doctor.
This activity, have we tried it in our last class?
Not yet.
Not yet. Okay, all right. Then we'll try it. Okay. Now, so we are going to try this activity, eh? All right. Okay then. Activity 2.4. We have water flows in a triangular channel, eh? So it's a triangular channel. Side slope 1.5. Now it says H. H denotes the horizontal scale. So I have 1.5. This is horizontal, this is vertical. So the bottom slope given is Chezy coefficient. Now, Chezy coefficient is given. So we know we are going to use Chezy formula already. The depth of flow is 2 meter. And then find the rate of flow and the average velocity. Well, you can find the velocity first, then, uh, then Q would be A times V. Now, based on Froude number, determine the state of flow. Then that means another part of the question would be you need to determine the state of flow based on Froude number. Okay, now, um, let's try this out. Can I have Liana, could you continue to give me the area of flow, the formula, please? Liana,
Yeah, Doctor.
could you give me the area of flow?
ZY square.
Okay, thank you. So Z would be 1.5, right? So this would be, agree?
Betul, Doctor.
Okay, thank you. Liana, continue, please. Okay, now, um, what is the formula for weather parameter?
Two Y square root 1 plus Z2.
All right. Okay, now, of course, why I need to find A and P because my Chezy formula, or I could write this as CR half S not half, or this would be A times CR half S not half. This is my Chezy formula. So I need to find my hydraulic radius. C is given, S naught is given. So the only unknown is R. I can find it since Y is provided. Now, um, this depth of flow, actually for uniform depth of flow, typically the symbol that we use is Y, not subscript, because it's not uniform flow or depth of normal flow. So you have Y naught equals to 2. We in later chapters, right, we are going to use this symbol why not for uniform flow. So I'm going to introduce why not here first. So I have two, 4, 1 plus 1.5 squared. So what will be the vector parameter, Liana?
$7.211.
Okay, great. Thank you. So you are giving me in 4 significant number, huh? Great. Thank you. Okay. Now, therefore, I can already solve for my velocity of flow. So I have CR to the power of half S naught half. Velocity is equal to 67.4 times my hydride radius would be 6 divided by 7.211. Now, I don't mind you solve hydride radius first. That means you solve it first, all right? Then you substitute the value here. It doesn't matter, all right? Or you can write it straight away. Okay, so I have 0.0002 to the power of half. What will be the velocity? Any beside Liana, who else can give me the velocity? I'll check out the who else. Okay. Harith Dahlan. Is Harith there?
Yes.
Okay, Harith. Could you give me the velocity value?
0.8695.
Okay, great. Thank you. Meter over second, eh?
Yes.
Okay. Now, once you have the velocity, therefore, you can actually find your rate of flow already. So basically, Q is equal to A times V. Okay, either way, you can actually find Q first, then V would be Q divided by A. Or you can find V first, then Q would be A times V. All right. So therefore, 6 times 0.8695. Harith, continue please.
5.2169.
All right, great.
Oh,
4 significant number, right? Okay, thank you.
okay. Okay.
All right. So this rate of flow will be 5.216 meter cubic, eh? All right. Now, let's continue. Find the rate of flow and okay, based on Freud number. So you need to find Freud number. Freud number is velocity divided by, you know, this is gravitational effect, right? So we have square root GD. Now, you need to find hydraulic depth. Hydraulic depth, okay, is given as A over T. Therefore, you need to find T. What will be the T here? Could someone give me Harith? Continue, please. What is the T? The what? The width.
Two
Let's see.
2ZY.
All right, great. So therefore is so is 6 meter. Am I right? Correct 6 So A would be 6, therefore is 1 meter. So fruit number is, velocity is 0.8695 divided by 9.81 is the gravitational acceleration divided by 1. So therefore, now I would like to have Chua Zhen. Chua Zhen.
Yes.
Okay. So what is your fruit number?
Uh, 0.2776.
Okay, now if I ask you to classify the state of flow, what state of flow it is?
It is subcritical state.
Why?
Because it's less than 1.
Okay, great. Thank you. So it's less than 1 is subcritical condition, eh? Okay, thank you. All right. So there you have it. Simple, eh? Straightforward. Okay, let's look at the next. Oh, I didn't. I thought I have another slide. Okay. Okay, now, let's look at this. Here's the thing. You know this. Let's go back to this equation. Okay. You know this Chezy roughness coefficient or Manning roughness coefficient, right? The question could give you the value directly, or okay, or you can read it. The question will give you the description of the channel, so you are going to read it from the tables provided, or okay, you they are formulas, all right, given to you to find, for example, the Chezy coefficient. You have Bazin formula, you have Ganguillet-Kutter formula to find the Chezy coefficient. Now let's look at some of the values. Now this is values of Chezy coefficient. If you look at this, right, many groove height of flood water channel is clean. Now Chezy value is very high for smooth channel, and it is getting smaller as the roughness increases, because like I told you last class, the Chezy coefficient is actually directly proportional to velocity. If the channel is smooth, we'll expect higher velocity. All right, so therefore, okay, Chezy would have higher value lah, because it is directly proportional. Now meanwhile, for Manning, because it is inversely proportional, you will expect, all right, the Manning value to be to increase, okay, as the roughness increases. Okay, so if Manning is a large number, the velocity will be small. Okay. Now let's look at this Manning roughness table. Now look at this concrete. All right, concrete channel, concrete bottom. It has Manning roughness range, in terms of 0.015, 0.02. Okay, wait, somebody is joining. Okay, now as it goes rougher, right? Okay, this is concrete as well, 0.02. Okay, this is examples of the condition. Now as it go rougher, the surface of the channel is rougher, you expect larger Manning. Look at this, dense width high as flow depth 0.05, compared to earlier when we look at the concrete, right, it's about 0.015, right, 0.018. This is higher Manning coefficient. Now look at this river with irregular alignment. That means it's not a straight river, all right, but it's bending. Okay, so the Manning value is so high, which is 0.125. What else? Okay, now look at this. So now, this is considered surface flow, okay, or it is considered open channel flow as well. But of course, there are cases where you have water ponding. That is different story, right? Because it's not flowing. But when the rain comes down non-stop and heavily, then you expect flow to occur on the surface, all right? So look at this, Manning roughness 0.11, which is huge compared to the concrete that we have looked at just now, which is 0.015, all right, at that range, all right, plus minus. This is, you can see, all these actually restrict the flow. That means these are the roughness characteristics. So you have, this is This is grass swale. It's called swale. The term is swale, SWALE. So this is a kind of open channel as well, but it's known as swale. So you have short grass, tall grass. Tall grass has higher Manning value. And then you have Bazin coefficient. Now Bazin coefficient, there is a formula where you can use the Bazin coefficient to get to the Manning and Chezy coefficients. Okay, now we have looked at this. I'll go back because I haven't touched on the Ganguillet-Kutter yet. Okay, now Chezy roughness coefficient can be determined using Ganguillet-Kutter and Bazin formula. Okay, either we can give you can read it from a table, or we give you the value straight away, or we ask you to find using Ganguillet-Kutter and Bazin formula. So for Bazin, if you are using Bazin, of course, we'll give you the Bazin coefficient lah. If you are using Ganguillet-Kutter, therefore you will give you Kutter's coefficient, or or we could give you C and ask you to find a Kutter coefficient and also Bazin coefficient, right? Either way. So this is Ganguillet-Kutter. If you look at this formula here, Ganguillet-Kutter, to find Chezy roughness coefficient value, it actually depends on the slope of your channel, the longitudinal slope of channel, the Manning roughness, and also the Hydride radius. Okay, meanwhile for Bazin, right, it depends on Bazin coefficient and also the Hydride radius. Okay, all right. Wait, this is from where? Okay, oh, just earlier, I think I misplaced my slide. Okay. Right. I already touched this earlier. Okay. Let's look at this activity. Activity 2.5. Okay. Here's the thing. On activity 2.5, Cutter's end is given. Okay. So you know that if Cutter's end is given, you can use this Cutter's end to find the Chezy coefficient. Then you can solve for the question to find velocity and discharge. Okay, now let's try this. I actually need all of you to try out the formula, because this Ganguillet-Kutter formula is a bit it's straightforward, okay? But you need to know how to apply the formula, because you need to have, the numerator divided by its denominator. You need to have proper brackets in your calculator. So let's try this out. Okay. Okay, activity 2.5. Calculate velocity and discharge in a trapezoidal channel. So you have a trapezoidal channel having a bottom width of 20 meter. Oh, this is a very wide channel, 20 meter. With bottom width, side slope 1 to 2. Okay. Dear Rushdie. Dear Rushdie, are you there? Dear Rushdie, are you there? Fan Kang Bao. Kang Bao, are you there?
Yes, doctor.
Okay, great. Kang Bao, could you help me? All right. Give me the side slope, please.
Slight slope is given by the question, right?
I know, I
The
know.
height
So
is 1
this is
and
this is
the
2. Huh?
horizontal slope is 1 and the vertical one is 2.
Okay, great. Okay, that's the purpose I asked you, you know. All right. I thought you will give me 1 to 2. All right. Now, so my Z would be what? Come on.
That will be 0.5.
Okay, great. Which is 1 over 2, right? So this is 0.5. Now, help me, continue helping me, okay. Now, the depth of flow would be 6 meter. Okay, cutter N is 0.015. S not. Now, this is not Manning's N, be careful of the question, Okay. Now, what's next? What should I do?
We should find the area first.
Okay, area first. Why?
Because in order to calculate the velocity, we have to get our area and the weighted perimeter.
All right. Yes, you are right. Actually, we need to find the area, weighted parameter, because we also need to calculate this Chezy, Ganguillet-Kutter's Chezy value, right? So, Chezy coefficient. So we need that. Okay. Of course, we also need the hydride radius for our velocity calculation. All right. So to get, so the next step would be this. Could you give me the formula, please?
The formula of area of trapezoidal is by plus zy squared.
Okay, answer please.
138.
138
Yeah.
point.
There's not that decimal place.
That means 0.0 lah.
The whole
Am I
number,
right?
yes.
Okay, thank you. It's a round number. Okay, thank you. Okay. Thank you, Kang Pao. Okay. You must be stressed and I keep asking question for you. Answer from you. Okay, I need somebody else. Okay. Yuzaimi. Yuzaimi, are you there?
Yeah, that
Okay, great. Yuzaimi, help me continue. Give me weighted parameter, please.
uh, b plus 2y square root 1 plus z squared.
Okay. Help me calculate this, please.
Um, $33.42.
Okay.
33.
Again?
33.
83,
33. 33.
53.
33.
33, okay. 33, okay. Thank you. So it's 33.42. Correct,
Yeah.
Okay, thank you. Okay, please continue, So I already have this. Now, in case, right, I want to calculate my hydroid radius straight away. Could you give me the value of hydroid radius, please?
Um, 4.129.
Okay, wait, I need to check first. Because we are going to apply it in Ganguillet-Kutter. I don't want it to be wrong. Uh, Okay, correct then. Okay, 4.13. Okay, thank you. All right, so the next step would be, I will show this guy here. Okay, so we already have hydride radius, eh? So the next step would be we need to find the Chezy coefficient already. So, Chezy would be okay. Could you please help me calculate this, all of you? What would be my Chezy coefficient using Ganguillet-Kutter? Tuan Muhammad Fikri. Tuan Muhammad Fikri ada?
Yes, madam.
Boleh kirakan tak? Chezy
Kejap,
coefficient.
tengah kira lagi.
Alright. The others also help me check this.
76.77.
What is the unit?
No unit.
Okay, great. No unit. Manning and Chezy coefficient. There is no unit for them. Okay. So you have this. After that, you can solve the question already. That means the question asks for velocity and rate of flow, right? So therefore, let's just go back a bit. Okay, is this the one? Yeah, correct. Okay, this is the one. So the question asks for velocity, okay? What will be the velocity?
(11.031 meter per second).
11.01.
031.
Okay. Okay. I'll just use for significant number. Then discharge should be AV. A is 138, eh? So Q is 1000. What is the value?
1522.28.
Okay. So this would be it. All right. So you got it. All right. So you have found that's the way. That means if I give you cutter, you need to solve for Chezy roughness coefficient first. Then you can continue solving for velocity and discharge. All right. Okay. So this is the one. Okay. Yep. Correct. Okay. Now that's the importance of four significant number. If all of us use four significant numbers, all right, in our answer, I believe our answer will be the same lah for everyone, all right? Because I think in this answer, some of them I use 5 significant number, okay, and some of it, for example, this guy here, the flow area, I use 3 significant number. So there's some, minor discrepancy lah, right? But this is negligible lah, basically. All right, it's the same. Okay, the next activity, 2.6. Okay, now we have looked at the formula to get to Chezy coefficient. Okay, so now is the Manning, the Bazin coefficient. That means we are using Bazin equation to find for Chezy coefficient. Now find equivalent Bazin coefficient M for activity 2.3 and compare with Chezy coefficient. Kutter N and M. Actually, this one is activity 2.5. There's error there. I forgot to change the numbering. It says find equivalent Bazin coefficient, compare with Chezy coefficient obtained and compare with Chezy coefficient obtained from Kutter and Bazin. Not sure what the thing. Okay. Oh, okay. I think I know why. Okay, now in this case, right, you need to look at the Bazin M from the tables. All right. Okay, from the tables, that means let's go back to the tables. Bazin coefficient, you have this is so basically if you look at Kutter's N or Manning's N, the value of 0.015, okay, represents concrete. Okay, for example, in this case, you have concrete. Can I ask you one question? For example, right, let's take a look at this concrete form, no finish. Can I ask Kang Bao again, are you there? Okay, Kang Bao, if I have a range for concrete, that means Manning N, right? If you look at here, the Manning N value, there's a range. And then let's say my question say, if I'm going to use a concrete form, no finish channel, what Manning N should I use if you are given this range?
The biggest value.
Louder, please.
For the Chezy is
Oh no. This Manning N. Let's not look at Chezy. We look at this Manning first. If I ask you a question, if I katakan kan, my question, saya cakap, cari Q sekiranya that open channel, alright, the surface of the open channel is of concrete form, no finish. Use Manning formula to find the rate of flow. So if I ask you to use Manning formula, you need to get the Manning coefficient, right, from this table.
yes.
Okay, so which value you want to use for the Manning coefficient? You have a range kan? Kalau tengok kat sana ada julat kan, 0.01 hingga 0.013 hingga 0.017. Jadi nilai mana yang nak ambil?
I will get the bigger value.
Why?
Because to get the largest Manning,
You get smaller velocity, right?
yes.
Okay, so why? So if you use 0.013, you get higher velocity. If you use 0.017, you get slightly lower velocity. Okay, now the easiest way is you can use average. That means 0.013 plus 0.017, you divided by 2 lah. That means get the average of it. That will give you the average n lah. Am I right, Kampao? Now, to explain why you need to use 0.013 and 0.017, actually you need to go to site. That means you need to know the real condition of that concrete form, no finish, whether it's rough finish, whether it's very rough, okay, or whether it's smooth. So if it's rougher, your expect velocity will be smaller. That means you can use 0.017. If you are guessing the velocity is higher, you'll use Manning N 0.013. Okay, so when you graduate, when you become an engineer later, normally before you design, you need to go to site first, or you can either one is site, or if the channel is not there yet, you need to, based on your experience and based on what workmanship of your workers you have seen, right? You can actually use you can actually assume any range of Manning, okay, based on the the channel that is going to be constructed lah, because it depends on the condition of the channel. Okay, I hope you are clear. Bergantung tapi kalau nak memudahkan ambil average lah. Kalau tidak, actually if you are using 0.013 or if you are using 0.017, it's not wrong you still get full mark, okay, unless I ask you to justify why you use that number. Okay, all right.
Okay, thank you.
Thank you. All right. So let's go back. Basically, if you look at this, just now we look at concrete, right? So basically, similar to concrete would be Bazin coefficient M of 0.21. I guess the question would ask you to use Bazin 0.21 to solve it. Okay, Bazin 0.21. Okay, so you need to find the Chezy coefficient, then you compare it. So try this out. Try applying this formula, then compare it. This is Chezy from Bazin and Chezy from Ganguillet-Kutter. You are using the N Kutter or N Manning lah. Okay, so this is a similar one. Okay, almost similar. Now, can I ask somebody? Let's see. Okay. I want to ask Siti Zulaiha. Zulaiha ada tak? Siti. Siti Zulaiha ada tak?
Ya saya.
Siti Zulaiha nak tanyalah. Okay, kalaulah tengok value Chezy dengan Chezy from Bazin and Chezy coefficient from Ganguillet-Kutter, right, value? They are not exactly the same. Why? Kenapa berbeza nilai Chezy? Ataupun Zulaika, you assume dia patut sama. Adakah dia patut sama?
Tak.
Kenapa?
Sebab ada, saya lupa lah apa nama dia.
Ada apa? Okay, tadi baru kita tengok persamaan Ganguillet-Kutter kan. Kita kata Ganguillet-Kutter dipengaruhi oleh slope, dipengaruhi oleh Manning N or Cutter's N, dipengaruhi oleh Hydride Radius kan. Manakala kalau Bazin dia dipengaruhi oleh M, alright, the Bazin coefficient and also Hydride Radius. There's no slope effect kan. Jadi berdasar sebab actually where does all this formula come from? It's actually from experimental, from dimensional analysis. So you have all this formula. and the variables, all right, of the formula used are slightly different. Therefore, you have slightly different answers. Boleh eh? Everyone? Okay. And Zulaika, thank you eh. Okay. Walaupun dah
Okay.
lupa. Okay. Jadi sebenarnya bergantung eh. Kadang-kadang ada pelajar yang tanya saya, bukan jawapannya patut sama ya. Saya kata sebab parameter yang digunakan untuk bangunkan persamaan tu adalah parameter yang berbeza. Jadi memang jawapan dia takkan samalah eh. Okay. Okay. Just a second, I'll check how many more activities. Okay. All right. I think we are last two lah. We are going because it's already quarter to 12 o'clock. So I guess we are going to do two more exercises. Then you can try the rest of the activities at your own pace. So let's try out.
Doctor,
Yes.
may I ask about why just not activity 2.6, the Bazin M value used 0.21?
The Bazin to 1, the Kutter 0.015. Am I right?
Yes, but
Okay.
why the Bazin value used 0.21?
Okay, here. The Kutter's N, we are going to look at the Manning's N, is similar. Okay, if I look at this, 0.015 is actually the type of channel is concrete. Am I right?
Yes.
Okay, because it won't be, it won't be grass or whatever. Okay, for example, in this case, right, is Manning will be higher for natural channel, so therefore it's concrete. Okay, we assume that the surface of the channel is concrete. So let's look at the basin. So what is similar characteristic of the channel would be concrete, right? Let's look at concrete. The only concrete we have here is the second line one, right? Am I right? We have concrete here.
Yeah.
So the equivalent basin M is 0.21. Can I?
Can. Okay, thank you, doctor.
So actually that's the meaning of the question. Actually, I wrote the question, but I forgot what the question wants. Actually, they want you to compare to get the Chezy coefficient value and see if you are using basin and you are using Cutter's N, right? Whether it's the same or not. All right. So, all right then. Okay. I think I'll skip this one because I think this is repetitive. You try this on your own, Try out on your own. Okay, now let's try this activity. This is slightly different where you have to determine the bottom slope, since you need to determine the bottom slope, okay. What activity? I think I need to check. This should be activity. Let's use activity 2.7 lah, the earlier activity, which is this one here. Okay. So let's see what is the question. Find the bottom slope. Okay. So Q is given as okay. This one, the characteristic of the channel is the one in activity 2.7. So Q, the discharge would be 50 in this case. Depth of flow is 3 meter. Right. And then you are using this channel, Okay. So you cannot, because you need to solve for S0. You cannot use this S0 already. You can only use the dimension of this channel. So I have this is 10 meter. This is 1.5. And the depth of flow is 3 meter. Okay, it's given already, 3 meter. Yeah, I'm right. This is a question. Okay, so let's try this out. Okay, so you have there. Is there Manning given? Yeah, it's 0.012. Okay. Okay, so since Manning is given, I'm going to use the Manning roughness, Manning flow resistance equation. So this would be, now I need to find A and P. Can somebody help me to calculate this, please? Am I right? 30 plus 13.5.
Yes, doctor, yes. Right.
Okay, great. Thank you. So the weighted parameter would be, now this one I cannot calculate myself. You need to help me. Okay, help. Solve this, please. 17 point something maybe.
20.82.
Again?
20.82.
Okay, thank you. All right. So meter, so my hydride radius would be, so this would be 2.9.
2.089.
Okay, great. So you have solved for the hydroid radius already. So therefore, let's continue. Oopsie. So therefore, you are going to have, now, just now we have this Manning equation, right? Going to rewrite this to 1/2. Okay. The unknown is S0. So I'm going to rearrange this in terms of S0. So I have, so S0 is, now in order to get rid of my square, right? Sorry, this half power, right? So I need to times 2 to the power. So what I did is, since I cancel this out here, this is square here. Okay, all right. So that means times 2 lah the power. So Q would be 50 times 0.012 divided by A is 43.5 times 2.089 to the power of 2/3 square. So S0 is, it must be a small number, because so far in our question, right, in all those activities we have learned, we know that S0 is a small number.
0.00007.
How many zeros? 3 zeros.
4.
4, 7. Yang lain sama tak?
Sama, tapi saya buat 7.124 kali 10 kuasa negatif 5.
Sama 7,124 kan?
Sama-sama.
Okay, great. Okay, unit, what is the unit?
No unit.
Okay, great. Thank you. Okay. No unit, because it's a length scale divided by length scale. Slope is actually vertical divided by horizontal. You get the slope. Okay. All right. So, all right. Correct lah. Oh, I think okay. So, now, I guess for today, I want to stop here, but I want you to try on. Okay, here's the thing. Boleh tak kita cuba activity 2.9, 2.10 on your own, okay? On your own. And then and activity 2.11 on your own. Then we'll just discuss the answer next class. Is it okay? Why not?
Okay.
Great. That's good. Okay. So, therefore, I want you to try on this activity from 2.9 or try as many of activity as you can. Then we'll look at the solution on our next class lah. All right. So I guess we'll stop for today because sometimes too many activities you'll get bored, okay, with me. Okay then. So I'll see you next class then. Remember to write to fill in your attendance,
Yes, madam.
Okay, great. I'll see you in the next class. Thank you.
Thank you, madam.
Thank you, Doctor.
Thank you, doctor.
Thank you, madam.
Thank you.
Thank you, Doctor.
Thank you.
Thank you, Doctor.
Thank you, doctor.
Thank you.
Thank you, doctor.
All right. Thank you. Thank you.
Thank you, doctor.
Thank you,
Thank
doctor.
you. Thank you.
Doktor,
Ya, saya tak apa.
sometimes
Sama
kan
ni.
saya terpening lah antara macam nak kira Z tu sebab because the previous question you divided the Z, right, to get the Z 0.5 1 divided 2.
Correct.
But this question you didn't divide it. How to differentiate, madam?
Because it's already one.
So it's already
The vertical
it's just like that
scale.
only. No need.
Actually, this is the scale for the side slope.
Okay.
The vertical scale should be 1 in order for you to get Z. This 1 to Z is actually the dimensionless scale of your side slope.
Oh, okay. Because I thought it have some style to differentiate it, so it's just like this lah.
As long
Okay,
as
okay,
you
got
get,
it.
the Z would be where your vertical is 1.
Okay.
All right.
Thank you.
You're welcome.
Thank you, doctor.
You're welcome.
Thank you, Doctor.
You're welcome.